Hi everyone, welcome back to another video, and today we're going through the factors influencing annual hydrographs. Remember, this is annual hydrographs, not storm hydrographs, so there is some difference. Even though the factors will be very similar, what we're going to do on the diagram is going to be quite different, so make sure you're aware of the two differences. So annual hydrographs are basically annual in a year's time, so therefore we need to split our time into a year's period. I've simplified it. Usually you get your months, so January all the way to December, but I've simplified it to the seasons. Obviously, this is the northern hemisphere with winter in around January and December, summer in July, but it is not common you see it like this. You see it more as January to December in the months. I've done this to simplify it so you can kind of visualize it better. But remember, when you're drawing it or when you're seeing it in an insert, for example, it's going to be the months probably. So let's introduce our factors, but first we have to separate them into climatic factors, which is rainfall and temperature and stuff, and basin characteristics, which is what's going on the floodplain and around the river. So our first factor is the type of precipitation, and we're going to focus in on snow or rainfall. And rainfall is pretty simple. When it rains, you're going to have water directly entering the channel, and also you're going to have true flow, you're going to have surface runoff, and then at the last, groundwater flow. So let's say you have a lot of rainfall in the winter. Because it's going to directly enter the river eventually, it's gonna follow a similar pattern. So if you have low rainfall in the summer and high rainfall in the winter, your river discharge is basically gonna be that high discharge in the winter, low discharge and high discharge. So basically, high rainfall, these two areas, it's gonna reflect in your discharge. Something different is going to be snowfall. You get this. When you have snowfall, the snow doesn't go into the river. Some snow does, but the snow that lands on land, it's not going to enter the river until it melts. And basically what this means is you're going to have precipitation in the winter time, but that is not going to increase your river discharge essentially. So during your winter time, you're going to have pretty low discharge. But when the snow starts to melt, then you're going to have a lot of discharge, a lot of water flowing in really fast. So what you're going to see is around spring, maybe summertime if it's slow enough, you're going to see a really sharp increase in discharge. Then it's going to slowly go back down to winter time. So this is the difference between snow and rainfall. Snow being a delayed thing until temperatures rise, whereas rainfall is kind of reflective of what's going on essentially. Now let's move on to evapotranspiration. Evapotranspiration is pretty simple, evaporation being water leaving water, and transpiration being the water that is lost by plants. And basically, the higher the evapotranspiration, the less water can enter the river. So if you have a lot of trees and the temperature is quite high, then you're going to have a lot of evaporation and you're going to have a lot of transpiration. This means any water that lands on the ground, for example, that is supposed to enter the river through true flow, is going to be lost. So let's say you have high evapotranspiration in the summertime because temperatures are high and there's probably a lot of trees that time. If you have high evapotranspiration, then you're going to expect your discharge to be lower. So it's going to be something like this. It's not going to be really intense like a more direct factor like rainfall, because this is more background and it's going to, assuming constant rainfall throughout the year, then it's going to look something like a small dip, but it's still a prominent factor nonetheless. So this is how evapotranspiration affects discharge. It just kind of decreases a bit whenever you have high ones. Now we're moving on to temperature, which is very similar to type of precipitation and evapotranspiration, because the temperature just affects the timing and the magnitude of the effects of these two. So obviously for snow to melt, you're going to need higher temperatures. And the high temperatures can occur in spring, but sometimes they might be really slow. Sometimes they might happen in summer, or sometimes they can be quite fast and happen in early spring. So it depends on what the temperature is, and obviously the weather will change quite a lot every year, so it's not going to be the same. So one year you might have very, very cold springs. So you're not going to have a lot of snow melt in springtime, and maybe it's going to look something like that. But if you have very hot springs, for example, then it might look something like this. So there is just a lot of variations, a lot of difference that the timing can affect it, and also the magnitude. If the temperature suddenly shifts up really high, maybe there's an anomaly in that year, or maybe there's climate change happening and every year it's going to get hotter and hotter, then maybe instead of, let's erase this. Maybe instead of a gradual snow melt, something like that, you're going to get really, really high snow melt because of higher temperatures, which is something like that. So that's how temperature can affect the type of precipitation or snow. Obviously, if it's colder, then you're going to get snow. If it's warmer, then you're probably going to get rainfall. Now and it's going to be really similar to evapotranspiration because, well, if you have higher temperatures, really, really high temperatures, then you're probably going to get a lot of evaporation and probably more vegetation unless you have a drought or something. But assuming not, then greater temperatures will mean greater water loss, and therefore it's instead of something like this, it's probably going to be more severe like this. And the timing as well. Again, it's not always guaranteed that you have really, really hot summers. Sometimes you might have hotter summers more towards the springtime, sometimes more during the autumn time. Again, there's a lot of changes, so there's no one correct answer to any of this because every location is different, right? This is looking at the northern hemisphere, but it's going to be different in the southern hemisphere. And obviously in different latitudes, you're going to get different temperatures, different rainfalls. So these factors aren't definite, they're not like concrete, and it's up to you to understand what these factors mean and then interpret any flow regimes, river regimes yourself. Now we'll move on to intensity and duration. So I've split this into storms, monsoons, and drizzles. And basically, the more intense your rainfall is, the higher discharge is going to be because obviously there's more rainfall concentrated in a small period of time. On duration, obviously, the longer you have rainfall, the more discharge is going to build up. So if we look at drizzles, for example, if you have drizzles all year round, then your discharge is not going to increase that much. It might be something like that. But if you have very periodic storms, so sometimes you get hurricanes or typhoons and stuff, it might be very fluctuating, and it might be sudden increase, then goes down, then sudden increase, then goes down. And there's going to be a lot of things, essentially. So if you look at this one, the drizzle is going to be maybe more duration, but less intense. Storms going to be very short duration, but very intense. But then there's another thing, which is monsoons. And monsoons, if you have experienced them, happen for quite a while. They can be 3 months, can be 6 months. And depending on when your monsoon season is, that's going to affect your duration, obviously. So monsoons are going to be kind of high intensity and also high duration. So you're going to see during non-monsoon season, so let's assume the winters are non-monsoon, then you're going to have really, really low discharge because there's not going to be a lot of rainfall. But then all of a sudden, when you enter monsoon season, it's going to spike up really much and then it's going to do something like that. So as you can see, it's a longer duration and it's really, really intense. So there's like kind of 3 different classifications on how you can affect annual hydrographs. Last thing about climatic factors is antecedent moisture, which is basically what is the saturation of the soil and what's the condition like beforehand. Obviously, we can't kind of see that, and it's going to be up to you to infer what it is essentially, because we don't know what the context is in the year before, and we need that context to understand what is antecedent moisture. So I can draw any graph on this diagram over here, and you're not going to be kind of able to tell that antecedent moisture is at play, but you could infer it essentially. So if you have high antecedent moisture, so a very wet soil because of very heavy rain the year before, then the soil is going to be less porous and less permeable, which means there's going to be more overland flow. And essentially, if the soil conditions are really wet, then any rainfall is going to have a really sharp increase and a very slow decline, essentially. But again, you can't really tell this unless you know the context beforehand. But if you're given one, you could say that it is potentially, so it's a suggestion and not a guarantee, that is antecedent moisture at play. And antecedent moisture is really similar to these two factors at the bottom in basin characteristics. Vegetation affects interception and infiltration, obviously, and also, I guess, a bit of transpiration. But essentially, if you have a lot of vegetation, then the interception means any rainfall is going to be trapped by leaves or any plants and stuff, and therefore less water is going to land on the ground, go into the rivers, and therefore you're going to have a lower discharge overall. It also increases the infiltration, so therefore overland flow or storm flow isn't going to be as high as usual. So having vegetation kind of suppresses it. But obviously you need to be aware of the timing of vegetation, because sometimes at winter you're going to have no leaves, and if there's no leaves, then you're probably not going to have a lot of interception. So you need to be aware or kind of guess the timing of when vegetation can bloom and when it will start to die out. And it's really similar as well. So you could infer that maybe in wintertime there's going to be less vegetation cover. So discharge-wise, it's going to be pretty high, something like that. But then in the summer, you're going to have more trees, so there's more interception, there's more transpiration, and there's more infiltration. So it's going to suppress the discharge during summertime when there's hotter temperatures and vegetation can grow. So it's going to look something like that, or vice versa if you're in the southern hemisphere. Again, this is not a guarantee. This is a theoretical thing, and if your conditions in your local area are different, then that's going to have some different things. Some vegetation can last all year round, for example. And lastly, we're going to move on to land use, which is the same thing as antecedent moisture. If your land use is kind of buildings and a lot of concrete, a lot of asphalt, then it's going to be very impermeable and it's going to not be porous at all. And therefore, there's going to be a lot of overland flow. So what a lot of surface runoff means is that it's going to be quite variable, because so it's going to be something like that. This is because when you have rainfall, so let's say there is rainfall that happens in springtime, then you're going to have a lot of water rushing into your river because it's impermeable, and therefore your discharge increases. But then very quickly after that, there's not going to be a lot of water to kind of have true flow, and therefore it's going to decrease really quickly. But then when another storm event happens or another rainfall event happens, then it's going to rise up really quickly and fall down really quickly. So there is a bit of difference between land use and antecedent moisture, because whilst high antecedent moisture, whilst wet soil means that the water is going to be impermeable, there will still be a lot of groundwater flow because the soil is wet that enters the river. So instead of being more variable, it's going to be more gradual decline. So it is going to increase quite a lot, but it's going to have a gradual decline compared to really sharp declines. So that is the difference between antecedent moisture and land use. And one last thing I want to mention, which I have mentioned in the last video about hydrographs, is there is one last thing that can kind of answer all your questions. And that factor is a dam. Because a dam can control basically everything, and whatever you want, the dam can do. So all year round, a dam can be a straight line, or it can be like this, or it could be curved if you want, because you can control the water, you can control the discharge with a dam. That's basically a lesson. But if you're answering an exam, it's probably better to use these other factors to show off a bit than just show off with a dam. But maybe if you're lacking time or something, you can use a dam. Other than this, one last thing I want to highlight is that don't treat these factors in isolation, right? Vegetation is not going to happen just by vegetation, and there's not going to be constant rainfall all year round. Everything changes, and you can mix snowfall. You can mix snow with temperature, and then higher temperatures can mean vegetation. Maybe land use is historical. There's no land use here. There's land use there, and it's going to be very variable depending on the location. And it's up to you to infer what's going on with the graph. Use these factors and think about them. How can you apply them, and try to join them together, because that's gonna help you elevate your answer and show you understand the complexities in geography. So this sums up the factors influencing annual hydrographs. Remember again, annual, not storm. And I'll see you in the next one, which is about storm hydrographs.